In this lesson, we are looking at factorization by using the method called completing the square. Now, you might ask, why? Why do we need to know this? Well, this is actually another technique of factorizing. Later on, you'll learn how to sketch quadratic functions. Also, you'll need to solve quadratic equations. So this is actually a good method. I want you to recall perfect squares. When we have a plus b all squares, we know that when we expand it, it's a squared plus 2ab plus b squared. Similarly, for a minus b all square, it's a squared minus 2ab plus b squared. And if you're given the expressions in this form, you could actually factorize it. Again, same with this. If you're given expression in this sort of form, you can factorize that way. Now, what if you're not given b squared? You're just given a squared plus 2ab or a squared minus 2ab. How do you factorize it? What I'm going to show you is actually a method called completing the square. Let's first learn how to complete the square, then we'll do factorization by completing the square. Alright, let's consider an expression x squared plus 2x. How do we actually factorize it? By completing the square. First, we can actually graphically represent this expression this way. Now, let's say this is a square. Alright, we know that we can assign this as x and x. Therefore, the area of this is actually x squared. Correct? Now, how do we represent 2x graphically? We added this in, which is 1, and this is x. Therefore, the area is 1x. Here, again, this is 1, and this is x. And the area is 1x. Therefore, this is represented in here. Now, we know that there's something actually missing here. Correct? In order to complete the square, what we do is we add in a little red square here. This, you can see that the measurement is 1 and 1. Therefore, we can complete this expression by adding 1, which is x squared plus 2x plus 1. So that is actually completing the square. When we consider x squared plus 2x, we can actually complete it to a perfect square by adding a 1 by 1 square. So this bit here represent x squared plus 2x, and therefore when we add in the square, which represent the 1, that actually is called completing the square. We therefore have a full square. Let's have a look at another example. This time we are looking at x squared plus 16x. The green bit represents x squared. The blue bit is actually 8 times x. Same here, 8 times x. Therefore, it's actually x squared plus 16x. Alright? So in order to complete the square, what do we need to do? We need to add in a red square, which is 8 by 8. And the area is actually 64. So therefore, in order to complete this square, we actually have to add in 64, and therefore, this is the product of completing the square. Now, I want to do a slightly different example, where this time is x squared take away 24x. Again, x squared is represented by this green bit. X and x. This time, we're going to take away 24x. So, what we do is, we put one in, another strip in. Okay? That strip here is actually 12. Here, 12. Now, we are actually taken away that and that. However, we are actually doubling the square that we have taken away. So in this case, we have to add in the square as well, which is 12 by 12. So therefore, we actually have x squared minus 24x plus 12 times 12, which is x squared minus 24x plus 144. So, this is actually the technique of completing the square. Now, generally, for any expression, x squared plus bx, we can represent it with this. What we do is, we add in a rate square, which is, the measurement is actually b over 2. So, for x squared plus bx to complete the square, we rewrite it as x squared plus bx plus b over 2 square. Now, this is the bit you actually have to write it down. To complete a square for x squared plus bx, you take the coefficient of x, halve it, and then square it. Okay? So, half of b and then square it. And then we rewrite the equation as x squared plus bx plus b over 2 all bracket square. Let's look at some example. What I'm going to do is apply completing the square to factorization. Looking at the first one, x squared minus 10x minus 6. Can we actually factorize it? Actually, no, we can't actually factorize it because we cannot find a pair of numbers which will give us a product of minus 6 and add that up to minus 10. So, what we can do is have a look at this bit first. X squared minus 10x. Now, how do we complete the square? Remember, to complete the square, we take the coefficient of x, bx, halve it, and then square it. So, take the coefficient of x, halve it, which is minus 5, and square it, which is minus 5 times minus 5, 25. So it's now x squared minus 10x plus 25. Okay, remember, 25 is half of minus 10 and then square. Alright, now if we do that and we rewrite this, how do we do it? That actually equals to x squared minus 10x plus 25. Because we introduced the 25 here, we actually need to take away the 25 as well, and then minus 6. Therefore, we can factorize this. This is actually x minus 5 squared minus 5 minus 26, that is minus 31. Right? What about this bit? X squared plus 4x. Again, let's have a look at that. X squared plus 4x. If we want to complete the square, actually equals to x squared plus 4x. Now, 4 divided by 2 square is actually 4. Because 4 divided by 2 is 2, square is 4. So, rewriting that, we will have x squared plus 4x plus 4 and minus 4 plus 2. Remember, when we add 4, we need to take away 4. So therefore, this becomes x plus 2 squared minus 2. This actually is a very, very powerful tool for factorization, because you will really need to know how to do this for solving some quadratic equation as well as sketching the graph. Now, the summary, this is very important. For any quadratic expression, x squared plus bx plus c, to factorize the expression by completing the square, you need to know these steps. First, square half the coefficient of x, which means it's bx over 2 squared. Then add to the expression, then take it away, so that actually is 0. We can then write the first part of the expression as a perfect square. These two will become a constant coefficient. Alright, let's look at a few more examples. First, how about this? X squared minus 12x minus 10. How are we going to factorize this? We can factorize it by completing the square. First, we'll look at how to complete the square for x minus 12x. Okay, so x squared minus 12x. Remember, we take half of this and then square it. What is half of minus 12? Minus 6. Squaring minus 6 is actually plus 36. So we have completed the square. We can rewrite this now as x squared minus 12x plus 36 minus 36 minus 10. And therefore, factorizing this bit is actually x minus 6 squared minus 36 minus 10, that is minus 46. We'll stop at there, completing the square. How about another example? This time is x squared plus 7x minus 4. Right. We know that we can complete the square for this part of the equation. Now, half of 7 is 7 over 2. Alright? Square it is actually that. So, what we can do is rewrite this as x squared plus 7x plus 7 over 2 square. Let's leave it at there. Minus 7 over 2 square minus 4. Now, can we factorize this? Yes, this is actually a perfect square. That equals to x plus 7 over 2 square. Correct? That's minus 49 over 2, square of that, minus 4. Actually, that is 4. So we can actually simplify that again. That is x plus 7 over 2 square minus, bring it to the same denominator, 49 minus 49 minus 16. That actually gives us x plus 7 over 2 square minus 65 over 4. So that is the answer for that. One final example. Let's have a look at this one. X squared minus 2x minus 8. I am actually going to write straight down, completing the square rather than do it separately. This is x squared minus 2x. You know minus 2 divided by 2 is minus 1. Minus 1 square is plus 1. Plus 1 minus 8. Therefore, this equals to x minus 1 square minus 9. That's all. So, factorizing, completing the square, you must remember these 3 steps. You square half of the coefficient of x, and then add to the expression, and then take it away. And then you write the first part of the expression as a perfect square, and then this will become constant. This is the end of the lesson, and we will do some exercises now. I'll give you some exercises from the book.